Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will begin a new unit which is called the exponential functions. Let's see what is an exponential function. The exponential function is a function of the form y equals f of x equals a to the power x, where x is a real number and a is a positive real number. So it's a function where the base is a number and the variable is an exponent. What you used to take in the previous years is that functions where the base is a variable and the exponent is a constant. Here what we have is that the base is a constant and the exponent is a variable. Now the most famous exponential function is y equals f of x equals e to the power x, where e is a constant and e is about 2.7, and we saw e in the previous unit, the unit of logarithmic functions. Let's see some tips about ex. Ex can be written as exp. We open parentheses, we write x, and then we close parentheses. In other words, e to the power 3x plus 1 could be written as exp. We open parentheses, 3x plus 1, and close parentheses. Such abbreviations could be used in GeoGebra, for example. Well, e to the power 0 is 1. E to the power 1 is e, which is about 2.7. It's a constant. E to the power negative 1 is 1 over e. And e to the power x is a positive quantity for every x belongs to R. In fact, it's strictly positive and it can never be equal to 0 because e is 2.7 and 2.7 to any power is positive. So e to the power x can never be equal to 0. So far, we must know that e to the power 0 is 1, e to the power 1 is e, which is about 2.7, e to the power x is strictly positive, and e to the power x can never be 0. Let's see this example. In each of the cases below, study if possible the sign of f of x. Remember, we need the sign of f of x. F of x is e to the power x plus 3. In fact, e to the power x is strictly positive and 3 is positive, so their sum is positive. Part B. Here e to the power x is positive and negative 4 is negative, so their product would be negative. Here we have e to the power negative x. This is positive. This is strictly positive because e to any power is positive. And here we have a ratio. The numerator is positive and the denominator is positive, so the whole ratio would be positive. Let's see the application. We have the same question. We need to study, if possible, the sign of g of x. Try to do this one alone. Well, we have minus 4ex is negative and minus 3 is negative, so the total is negative. Try to do the second one alone. While the first factor is positive, the second factor is negative because it's a positive quantity multiplied by a negative 1, so the total would be negative. The third case here, try also to do it alone. Well, we cannot tell here because x could be positive or negative, although ex is positive, but we cannot tell the sign of the first factor, and similarly for the second factor, we cannot also tell. The fourth one. Now the numerator is positive, the denominator is positive, so the ratio would be positive. Let's see the second application. Verify that e to the power ln x is x for every x greater than 0. Try also to do it alone. Let's see the solution. If we let y be e to the power ln x and we try to prove that y is equal to x, we apply ln to both sides. We get ln y is ln e to the power ln x, and if we simplify the right side here, we get ln x into ln e. Remember, ln e is 1, So ln y is equal to ln x, which means that y is equal to x. So y is equal to x, and at the beginning we suppose that y is e to the power ln x, so we can say that e to the power ln x is equal to x. So e to the power ln x is x. Let's see the first property. X and y are two real numbers. E to the power x times e to the power y is e to the power x plus y. This is similar to the exponent properties. E to the power x to the power y is e to the power xy, and e to the power x over e to the power y is e to the power x minus y, and e to the power minus x is 1 over e to the power x. These are the same as the properties of exponents that you took from grade 7. Let's see the second example. Verify that this quantity is equal to that one. We will see it in different ways. The first method, if we take the right hand side here and we go on until we get the left hand side. Now here I advise you to write e to the power minus x as 1 over ex and try to simplify. So this could be written as 1 minus 1 over ex over 1 plus 1 over ex, and if we take a common denominator in the numerator and in the denominator, we get ex minus 1 over ex over ex plus 1 over ex, and if we simplify by ex, we get ex minus 1 over ex plus 1, and this is the required solution. Now let's see another method. If we begin from the left side and we go on until we get the right side. Now here, if we take ex in common, we get 1 minus 1 over ex. Remember, we have to divide here. Ex divided by ex is 1, and 1 divided by ex is 1 over ex. And if we also take ex in common in the denominator, we get this quantity. If we simplify by ex, we get 1 minus 1 over ex over 1 plus 1 over ex, and this quantity, which is 1 over ex, could be written as e to the power minus x, which is the required solution. And the third method is, if we take both sides at the same time and we put a question mark until we get a true statement. Now here, if we cross multiply here and there, we get this quantity. If we expand, we get e to the power x. Remember, e to the power x times e to the power minus x. We add the exponents, we get e to the power 0. Negative 1 by 1 is negative 1, and negative 1 by e to the power minus x is negative e to the power minus x. And similarly for that side, then e to the power 0 is 1, and we can see from here that we get a true statement because everything on the left side is equal to everything on the right side. Now, which method is preferable? You can choose any method that you like. Well, this is the list as you see. Let's continue with this application. Try to verify this quantity alone. Now here, if we just take the left side and we go on until we get a 0, and we replace e to the power minus x by 1 over ex and e to the power minus 2x over 1 over e to the power 2x, and if we take a common denominator e to the power 2x, we get this quantity. You see here that ex minus ex is 0 and 1 minus 1 is 0, so it will be 0, and this is the required solution. Now, let's see the fourth application. F and g are two functions defined as follows. C and G are their representative curves. The question is to study the relative positions of C and G. Now, we studied relative positions before. Well, to study the relative position, we have to find the sign of f of x minus g of x, which is e to the power 2x minus 3 over e to the power x plus 1 minus ex. And if we take a common denominator, we get this quantity, which is minus 3 minus ex over ex plus 1. In fact, the numerator is negative, the denominator is positive, so the ratio is negative. Now, Mira or Rami, study, if possible, the sign of this expression. Mira states that this is positive because e power minus x is positive and 3 is positive. Ram states that the sign of e power minus x plus 3 cannot be studied since e power minus x is negative and 3 is positive. I think Ram's solution is not correct because e to the power minus x is never negative. Remember, e to any power is always positive, and it is strictly positive.